The project is going to begin with a warm-up exercise for your team in which you're going to modify a tic-tac-toe program. First of all, if I look over in my current folder, I have a little data file, a .mat file that's called Tic-Tac-Toe, and you all are somewhat familiar with these .mat files because you've actually been using them in the last couple of homework assignments. Taking a look at what's in that file, I can type load tic-tac-toe, hit enter, and everything in that file will load into my workspace window. So if I look at my workspace window, I have something called board. It's a 3x3 cell array. I have something called O and something called X, which clearly are the markers to play tic-tac-toe. If I want to see what this board looks like, I'm going to drag and drop a command here. The command imshow is short for image show, and it's used to actually display an image. And if I look at the arguments inside of imshow, I have board 1, colon, and that would indicate row 1 of board, all columns. I then have board 2, colon, row 2, all columns, and board 3, colon, row 3, all columns. If I go ahead and hit enter, I'm going to see an image of this tic-tac-toe board. If I want to take that tic-tac-toe board and I want to dock it into my screen so that it doesn't disappear as I'm trying other commands, there's a little curly arrow here, and underneath it it says dock figure. And if I click on that, it'll dock the figure right in my workspace, so it'll stay there. Alright, so now suppose I want to put an X into this board. I'm going to drag and drop a command here. And if we take a look at this command, it says board 2, 2, row 2, column 2, center of the board, set that equal to my X marker. So I go ahead and do that, and it replaces that center section of that board cell array with the X marker. If I then want to look at the result of that, I can run the image show command again, and sure enough I get an X in the center section. If I want to place an O, say in row 2, column 1, I can simply put board 2, 1 equals O. Executing that command will place the image of the O marker into the board array. And again, if I want to see that result, I run the image show command again, and sure enough, I've got an O in row 2, column 1. Notice that there's these orange warnings showing up every single time I do the image show command. We're going to talk about how to get rid of those warnings. Now we're going to run the tic-tac-toe function to see how it works. I have my tic-tac-toe board, and I see at the command prompt player 1 enter row and column for your X. So I'm going to go ahead and enter row 2, column 3. That places the X. Player 1, did you win? No. Now player 2 is prompted for his or her position, and player 2 is going to choose a 1 and a 3. That places the O. Player 2, did you win? No. Now we're back to player 1. Player 1 is going to choose a 2 and a 1. To place the X, no winner yet. Player 2, enter row and column. Player 2 is going to choose a 1 and a 2 because player 2 is not too smart. Player 2 does not win. Player 3 is now going to choose a 2 and a 3, which is not a valid command because that square is already occupied. So now player 1 is going to choose a 2 and a 2. And player 1, did you win? Yes, player 1 is won. So we get a message that player 1 is the winner. This program has a flaw. Let's run it again to see that. So I run tic-tac-toe. Player 1, enter your row and column. Player 1 picks the center column. Menu comes up. Player 1, did you win? Player 1 says yes. And player 1 is declared the winner, even though clearly player 1 has not won. So your first task as a team is going to be to modify the tic-tac-toe program so that the program itself determines when someone has won. So let's take a look at the tic-tac-toe.m file and see what's in there. All right, first of all, function name tic-tac-toe. Load tic-tac-toe. We know already that that loads the 3x3 cell array board image and loads the image for the X and for the O. All right, down on line 7 here, we see a new command, figure, Windows style, docked. What that does is it'll automatically dock that figure so that you don't have to click on that curly arrow and dock the figure into the window. The next line down, line 8, we see the image show for the board. And notice that I have added one property to that command that we looked at before, and it is initial magnification fit. What that does is it'll eliminate all those annoying orange warnings that say every time you show the board that it's being scaled to fit properly into the docked window, so we won't see those orange warnings anymore, which is kind of nice. All right, as we progress through the program, we've got that graphic image of the board, but what we're doing in the program is we have another numeric array that shows what players have made what moves. So if we look at line 10 here, you can see I've created a numerical array called board array, and it is initially filled with zeros. It's a 3x3 array filled with zeros. I have another variable I call player, which is going to keep track of which player is currently playing. If player is equal to 1, that means player X is playing. If player is equal to 2, that means player 2 is playing. You have done something extremely similar to this in Lab 10 with the DNA, where you had a task flag, and if that task flag took on one value, you were looking for a start codon, and if that task flag took on another value, you were looking for an end codon. Here, the variable player is my flag. If player is equal to 1, that means player X has a turn, and if player is equivalent to 2, that means that player O is currently playing. Moving on to line 13, I've highlighted a section of that code that says board array equal to 0. We know what this is going to do. This is going to look at that board array of numbers, and every spot in that array that has a 0 in it will be a true or a 1, and every spot that does not have a 0 in it will come back as false. So in other words, I'm going to get an array that has 1s in it in every spot where the board array has zeros or open spots. If I add all of those together, then I know how many open spots I have left on my board array, and my gameplay is going to continue as long as there's still an open spot. So moving down to line 15, I see if player is equivalent to 1. So here's my task flag going into effect. If it is indeed player's 1's turn, I'm going to ask player 1 to input a row and column for his or her X, and that input that the player puts in is going to be stored in a variable called square. Square is going to be a vector that has 2 entries in it. The first entry of square is going to become my row. The second entry of square is going to become the column for player 1. And the first thing that we do in this program is we're going to make sure that player 1 entered in a valid position for his or her X. Invalid positions would be a row number bigger than 3, a row number less than 1, a column number bigger than 3, a column number less than 1, or trying to place the X in a place where the board array was not equivalent to 0. In that case, we come back with some various error messages to the user and prompt that player to re-input a row and column for his or her X. Assuming the player finally makes a valid choice, we place that X in the board cell array, and we've seen that before, but we also place a 1 in this underlined numeric array that we're calling board array. And then we go ahead and show what the board looks like. Here's the part of the code that your team's going to modify, and that is, did player 1 win? And if I look at this, player 1 is allowed to declare himself or herself as the winner, and if they declare themselves as the winner, we break out of the loop and get a message that player 1 has won. So that's where you're going to modify the code. Now, assuming that player 1 does not declare himself or herself the winner, the code moves on and checks whether or not there are any more open spaces on the board. And if there are open spaces on the board, we switch our player number from 1 to 2. If there are no open spaces left on the board, we break out of the loop and determine the winner. Moving on down here to line 55, I see this piece of code is going to run if indeed it is player's two's turn. And if you look at all of the code under player 2, it's pretty much identical to the player 1 code, other than the fact that we're prompting player 2 for items, and when player 2 finally puts in a valid row and column, his or her O is going to be placed in that column. Just one more thing I'd like to point out in the code here. When we've outputted stuff to the user, we've used a lot of fprintf and disp commands to do so. Here's another option shown in line 99. I can use a little function called message box, or MSG box for short, and what that does is it actually brings up a little pop-up box, and what shows in the box is whatever message that you have in single italics. This is just another possible option. Once your team has completed the warm-up exercise with Tic-Tac-Toe, you're then going to select a game or a set of games to program, depending on the level of complexity at which you choose to work. The rest of this video is developed to give you some ideas for games and to also give you a look at some of the resources that we have developed for you. Hangman's a nice game. Here's a very simple version of Hangman. If I type in Hangman and hit enter, my word has 6 letters and I need to guess a letter, so if I just simply guess a letter, good guess, I have 1 letter guessed. If I guess another letter, say N, I've got another guess. If I should guess that letter again, I'm told that I've already guessed A and N. I need to guess a different letter, so let's say E. Got it again. I'm actually pretty good at this. B. Missed one. Wrong. You're down to 6 guesses. Q. Wrong. We're down to only 5 guesses. E. Already guessed E. C. Now I only have 4 guesses left, and I'm going to guess badly. We'll guess Z and Y and P. And 1 guess left. Oh, R. That was a good guess. All right. O and G. And we've won the game. So that's a pretty simple game. If you say you want to play again, it'll create a new word picked out of a word bank of words and simply prompt you for letters. And if you make 7 wrong guesses, then you lose the game. Now, of course, this could be jazzed up a bit. You could add some graphics that showed a picture of the various bad guesses. As they, first bad guess you show a head, then you show a neck, etc. You could add some sound effects. You could turn it into a 2-player game where each player gets to secretly enter a word and the other player has to guess it. You could even expand the complexity of this by turning it into something like a Wheel of Fortune, where instead of just a word, it's a phrase. There's a prize wheel. When it's a player's turn to play, they get to keep making guesses as long as they're making correct guesses. So there's lots of really neat things that could be done with this basic game. 2 key commands for something like Hangman or Wheel of Fortune, where you're looking for letter matches, are string comp and string find. There are lots of good dice games around, some simple, some not so simple. And to add a little bit of fun to a dice game, I've created a dice cell array that has images of dice, so you could add these to your program if you wanted to. So to take a look at this cell array, it's in a dice.mat file, and if I load that file, I will see in my workspace window over here I have dice. It's a 1 by 6 cell array. And if I want to take a look at what that looks like, I'm going to drag and drop a command in here. It's an image show command. And it basically says I want to show this entire cell array. I want to show row 1, which is the only row in the cell array, and all columns. So if I do that, I see that I have the 6 dice faces on a standard set of dice. I'm going to go ahead and dock that figure. If I want to roll the dice, a really nice command I can use for this is one that you have used before, the random integer command. So I have my roll is RANDI. The first set of values here is the range over which I want those integers to occur. So my minimum value is 1. My maximum value is 6, and then my second entry designates what size I want this roll to be, and I want it to be 1 row and 3 columns, which means I'm rolling 3 dice. So if I go ahead and hit enter, I get a random roll of 5, 5, 6, and if I want to show what that roll looks like, I can again use the image show command. And instead of showing everything in dice, all I want to do is show my specific roll. I've added this extra property for initial magnification so I don't get the orange warnings. And if I go ahead and hit enter, I now should see 3 dice, 5, 5, and 6. Sure enough, I do. If I'd like to do that again, I can do another random roll. Now I've rolled a 1, 3, and 2, and if I'd like to see that roll in my graphics window, I can run the same image show command, just specifying the roll, and sure enough, I see a 1, 3, and 2. Card games are a lot of fun too, and if you would like to add some graphics to your card game, I've created a couple of different card decks and saved those in a .mat file called card deck. So again, if I load in that card deck file, I'm going to see in my workspace window I have something called a blue deck and something called a red deck, and they are both 1 by 55 cells. To get an idea of what those look like, I don't really want to show all 55 cards at once, so let's start off with an image show. Blue deck, cards 1 through 15. And I see the first 15 cards in the blue deck, and I can see the way the blue deck is arranged is I have the 4 aces first, then the 4 twos, then the 4 threes, etc. If I want to see what the end of that blue deck is, to see why it is I have 55 cards in this deck, I can show cards 40 through 55. And I will see that I get the rest of the cards in the deck all the way through the kings, and then I have added a couple of jokers and a card that's face down that's blue, hence the name blue deck. If we do the same thing with the red deck, we'll see that it's just arranged slightly differently. So if I look at cards 1 through 15, I actually have all the cards for the suit of clubs, then I have all the cards for spades. So that's my arrangement. And if I look at the end of that card deck, cards 40 through 55, I will see that I finish with diamonds, and then I have 2 jokers and a face down card that is red. And depending on the type of game you're doing, you may prefer one arrangement or over the other, or you may even want to rearrange the entire deck to suit your game better. So if we want to shuffle a deck, there's a command that you have used in a homework assignment called ranperm. And if I create a variable called shuffle deck, ranperm52 will randomly arrange the values of 1 to 52, none of which will be duplicated. So if I run that, I see my output, and that creates a shuffled deck. If I then would like to pick some cards out of that deck, for example, I could use this command, player cards equals shuffled deck 1 through 5. We'll pick the first 5 values out of that vector shuffled deck, which ought to be 9, 47, 37, 5, and 43. And sure enough, they are. If I then want to look at the player cards in the blue deck, for example, I can run image show blue deck, player cards, and it will show me the 9th, 47th, 37th, 5th, and 43rd card in the blue deck. And if you are interested in card games, I created a simple little game called Beat the Dealer, and I will provide you with the code for this so you can get some idea of how you would create a card game. And this game is very easy. You just shuffle the deck and deal a card to the player and deal a card to the dealer, and high card wins. So here the player wins because he got a jack and the dealer got an 8. If I play again, then the dealer wins 10 over 3. If I play again, the dealer wins again, queen over jack. Play a few more times. And then if I choose not to play again, the program keeps track of the wins. The dealer won 4 times, the player won 3, so the overall winner is the dealer. Here's another idea for a card game, a simple game of memory. So cards are laid out in a grid. Face down, it's player's 1 turn, and player 1 chooses row 1, column 1, and that first card is flipped. Player 1 chooses, say, row 1, column 2, and that card is flipped. It's not a match. Cards are turned back over. It's now player 2's turn. Player 2 picks a 1 and column 1, and perhaps a 1 and a 3. Those cards are flipped. They're not a match. They're flipped back over, and play continues. Tic-Tac-Toe is a pretty simple board game. Now we're going to take a look at a few more complicated board games, and we're going to start with Mastermind. In Mastermind, the computer generates a 4-color secret code, and we can see here on the menu I've got 8 colors to choose from. And the player has to guess what the color code is and needs to get the colors correct and in the correct order, and has several guesses to do this and get some feedback from the computer. So for example, the player might guess blue, orange, red, and turquoise. And what the computer will produce is this little white peg, and what that white peg means is the player has not gotten any of the colors in the correct position, but one of the colors that the player guessed is correct, and now the player gets a second guess. So for example, I might do blue, blue, red, and red, and this time I get a black peg, and a black peg means that one of those colors is correct and one of those colors is also in the correct position. So if I start to make another guess here, maybe I will guess yellow, green, red, and pink. And now I get 2 black pegs, and that means that 2 of my colors are correct colors, and 2 of them are in exactly the correct position. Play continues. The user gets to continue to make guesses, and if the user successfully guesses the color code, they win the game. Another nice board game is Connect 4. Players drop red chips and black chips down a board and try to get 4 of their color in a row, either vertically, horizontally, or diagonally. The player with the black chips plays first, so perhaps he picks column 1 to drop his chip in. Player 2 picks column 4. Just to make this go fast, I'm going to have player 1 pick column 1, player 2 pick column 4, player 1 pick column 1, player 2 pick column 6, and player 1's going to win 4 in a row. Dr. Bucks created the board for the game of Dungeon, in which the player's been imprisoned in the dungeon and is trying to escape. And there are monsters hidden in the dungeon on the board that are hidden, and as the player travels around through the dungeon, they can collect swords, shields, boots of speed, and health potions, which do various things to increase health or attack ability or defense ability. And there are different levels of difficulty possible. So I'm going to pick easy. And the board appears, and there is the player. And the player has to navigate down to the door. So the player's up here on the left-hand corner. And if I just move right and perhaps down and to the right a couple of times, I get some good stuff, and I pick up the sword, and that gives me some more good stuff. And if I close down this board momentarily and look at this, I can see that I have my health status, damage, defense, and speed, and all of those good things are being fed back to me. Another nice board game is Othello. Othello is a two-player board game. One of the players has black discs and the other player has white discs. And player one with the black discs gets to play first. And player one is first asked if he or she has a legal play. And here's what a legal play is in Othello. A legal play for a black disc would be to put the black disc somewhere on the board next to one or more white discs, and that white disc would have to be surrounded. So, for example, this is the way Othello starts, the way it's set up right now. One place where one could put a black disc would be in this square right here. And that would surround the white disc to the left because there is a black disc on the other side. Another place a black disc could be placed is below this white disc. And again, that would surround it because there's a black disc above it also. A third option would be here, and that would surround this white disc by another black disc. And a fourth option would be above this white disc, and again there's a black disc underneath, and that white disc would be flanked. So if the player makes a legal play, can make a legal play, player one says yes, I can make a legal play, and player one is prompted for the coordinates of where to put that black disc, and player one enters 5 and 6. That disc is placed, and the white disc in between is flipped. Now player 2 is prompted, do you have a legal play? Player 2 responds yes, and player 2 enters the coordinates of that play, which would be, let's say, row 6, column 6. That is a legal play, and diagonally that black disc is flipped. Player 1, do you have a legal play? Player 1 responds yes. Player 1 enters the coordinates 3 and 3. And if we look at the board, 3 and 3 would be right here, and that is not a legal play. That's not going to flank any white discs. And indeed, if I hit enter, I get an error dialog box that says this move does not flank any white discs, and player 1 is prompted again, do you have a legal play? And this time player 1 enters in the coordinates 3 and 4. That would be here. That is indeed a legal play. And the white disc in between is flipped. Play continues until either the board is completely full or both player 1 and player 2 have to forfeit because they don't have a legal move. The graphics and game pieces that you've seen in this video were developed by Dr. Bucks and Dr. Osman, and should you choose to write a program for one of these games, these graphics will be provided to you on Blackboard. In addition, Dr. Bucks created a graphic board for Battleship along with game pieces for the various ships. If you have an idea for another type of board game that you and your team would like to work on, these boards are actually very easy to create, and Dr. Bucks or myself, Dr. Osman, we would be more than happy to show you how to create a board. It doesn't take very much time at all.